Welcome you all for strength of materials. Chapter number 1, simple stresses and strains. This is lecture number 1. I hope most of you are planning for TRB and few students are for GATE also. However, for both TRB and GATE, syllabus is same. Syllabus and concept coverage is exactly same. TRB students, any one of you, please unmute and tell me. Calculator is allowed or not? TRB students, Teachers Recruitment Board. Please unmute and tell me.
Sir, if you're talking about assistant professor exam, then calculators are not allowed.
Yeah, that's what I'm asking the students. Calculators are not allowed, right?
No.
So TRB, Teachers Recruitment Board, that TRB aspirants should note the GATE questions, which are all simple in calculations, right? You have to highlight those questions, right? They will be asked in the TRB examination without change in the numbers. Without change in numbers. Exactly, they will ask the questions. Right? So you have to note it, right? I will also highlight that this is possible for TRB, this is possible for TRB, like that. Okay. So you have to note it down. In addition to that, I discussed with our manifold people, right? With their guidance, I have collected the TRB questions, previous year engineering college questions and Polytechnic college questions also, Kerala questions. Then I have collected other state TRB questions also. Okay, right. So based on that, we will discuss in the classroom. Okay, right. So let us see the syllabus. For civil engineering students, the subject name is solid mechanics. For mechanical engineering students, subject name is mechanics of materials. Both are strength of materials only, right? For civil, right? Bending moment, shear force in the statically determinate beams only, not in the statically indeterminate beam. Only for statically determinate. For SOM point of view. For SOM point of view, right? In the structural analysis, you will study statically indeterminate case. Okay, right. Then simple stresses and strain relationships, theories of failure, simple bending theory means bending normal stress calculations, flexural and shear stresses. Flexure means bending, right? Then shear center, uniform torsion, buckling of columns, then bending normal stresses. Okay. So this is the syllabus for civil engineering. For mechanical engineering, stress and strain, elastic constants, Poisson's ratio, Mohr circle for plane stress and plane strain, thin cylinder. Thin cylinder also comes under plane stress category. Shear force, bending moment diagrams, bending and shear stresses, concept of shear center, deflection of beams, torsion, Euler's theory of columns, energy methods, thermal stresses, strain gauges and rosettes, testing of materials, then hardness test, impact test. Right. See, it looks a little bit more for mechanical engineering, little bit less for civil engineering. But actually, both are exactly same. Exactly same. Right. They are covering the basic fundamental concepts. Okay. Right. So based on the previous year questions, we are classifying. So based on the previous questions, we are classifying the chapters. Right. Simple stresses. Simple stresses, first chapter. Then second chapter is shear force diagram, bending moment diagram, bending normal stress, transverse shear stress, torsion, then principal stress calculation and Mohr circle. Very important chapter. Right. Then deflection of beams, buckling of columns, strain energy method. At last, testing of materials. Okay. Right. Now, all of you please answer. What is a formula for stress? What is a formula for stress? What is a formula for stress? Please answer. Formula for stress.
Force by area.
Very good. Force by area, right? So hereafter, don't say this formula. This is a fundamental formula, simple formula. Okay, right. Simple formula, right? What is a unit for load? What is a unit for load? Answer, please.
Newton.
Newton. Okay, right. Now, so hereafter you have to change your view, right? There are two types of loads, right? One is force. Another one is moment. Both are loads. Okay, right. For the force, the unit is Newton. For the moment, the unit is Newton meter. Right. Again, moment, right? Moment is classified into two categories. Bending moment. Bending moment and twisting moment. Bending moment and twisting moment. See, both are looking like same, right? But except unit for both Newton meter, right? Unit is Newton meter. Except unit, all the consequences of bending moment and twisting moment are exactly opposite. Okay, so that we will discuss later. So already I told this is a simple formula, fundamental formula. Hereafter you should not say this formula, right? Sir, what is a formula? We have to answer, sir, in the questions and all, right? See here, I'm going to write. See, first 2 hours will be like story, but you have to watch very carefully, right? These things will not be in the textbook, right? You have to watch very closely. See this. Sigma T, simple tensile stress. Okay, right. So formula is tensile force by normal area. Normal means normal to what? Normal to load, perpendicular to load, force. Okay, perpendicular to force. Right. Then simple compressive stress. Compressive load by normal area. Compressive load by normal area. Right. Then very important one, tangential shear or simple shear. Tangential shear or simple shear, right? P tan tangential force by shear area. Tangential force by shear area. Okay, right. Then thermal normal stress is equal to E coefficient of Young's modulus alpha coefficient of thermal expansion change in temperature. Okay, right. So far we have seen 4 stresses, right? So this is a frequently asked question in the state level public service examinations, right? Then bending normal stress. bending normal stress. Right? So formula is My by I. We will study each and every one in detail in the coming chapters. Right? Here we are giving the overview only. Right? My by I, general formula. 6m by bh square for rectangular cross section beams. For circular cross section beams, 32m by pi d cube. 32m by pi d cube. Right. So all these are related to bending normal stress. Okay. Right. Then transverse shear stress. Transverse shear stress. Right. Transverse shear stress. Right. So the formulas are VQ by IB. VQ by IB. Then this is a general formula. General means for any type of cross section and at any point within the cross section. Right. Then 3 by 2 V by BH for rectangular cross section beams. Then 4 by 3 V by pi r square for circular cross section beam. Right. Then torsional shear stress. Torsional shear stress is equal to TR by J. It is general formula. TR by J. Okay. Then 16T by pi d cube. 16T by pi d cube for circular cross section beam, solid circular cross section shaft. Solid circular cross section shaft. See, there are 7 types of stresses. 7 types of stresses. Okay. Right. Out of the 7 formulas, which is the easiest one? Tell me. Answer, please. Which is the easiest one? Simple formula, easy formula. Out of 7. Quick answer, please. All of you participate. You are all going to become an assistant professor. Participation is important. Whether your answer is correct or not, that is different. All of you, please participate.
Normal tensile stress, normal compressive stress.
Very good, very good. So these 2 formulas are very simple. Okay, right. So in the examination, mostly questions will not be asked based on this formula because everyone knows this formula: P by A, F by A, like that. Okay, right. Questions will be from this portion. This portion. Okay. Most of the questions are from these 3 stresses, particularly this one and this one, particularly. Okay, right. So 7 stresses are there. We are going to classify into 2, right? So the left side category 4, right? These first 4 are called as simple or direct stresses. Direct stresses, right? The last 3 are indirect stresses. There is no secret behind this title, right? It is according to our convenience. See, these are all stresses, right? What are the loads for the particular stress, right? So load for simple tensile stress is P tension. Load for compressive stress is P compression. Load for tangential shear is tangential shear force. Tangential shear force. Right. Then load for thermal normal stress is change in temperature. Change in temperature. Right. Then See, tensile force, tensile stress, compressive force, compressive stress, tangential force, tangential shear, thermal load, thermal stress. So load name and stress name both are similar. So we are classifying them as a direct stresses. Right? Next, come to indirect cases. Right? M is bending moment. Bending moment. So due to bending moment, bending normal stresses are developed. Normal stresses, very, very, very important information. Normal stress. So bending moment results in normal stress. Right? Don't forget. Right? Then shear force. Right? Shear force. V is nothing but shear force. Right? This shear force is perpendicular to the shear area. The shear force is perpendicular to shear area. Shear force is perpendicular to shear area. Right? Don't forget. Here, shear force is parallel to shear area. Okay, right. That is a difference between tangential shear and transverse shear. Okay, transverse means perpendicular. Right. It is also happening in the beams. Beams. Right. So what is a load? Shear force. Shear force is the load for transverse shear. Right. Then tau torsion. Torque is the load for tau torsion. Torsional shear stress. Okay, right. Now you can understand what are the loads: bending moment, shear force, twisting moment. Okay, right. These are the loads for indirect stresses. Right. So totally 7 stresses are available. Out of the seven, how many normal stresses are there? Tell me. Even though 7 stresses are there, how many normal stresses? Answer, please. 4. 4 normal stresses. Okay, 4 normal stresses, 3 shear stresses. Right? So we will teach all the 3 in a single slide. All the 3 shear stresses you can understand. Right? So not today, in the coming chapters. Right? 4 normal stresses, 3 shear stresses. Okay, 4 normal stresses, 3 shear stresses. Right? Yeah, V is shear force. V is shear force. Right? We are doing a SFD diagram, right? Shear force diagram. That SF, shear force, right? Q is moment of the area above the neutral axis or calculation point about neutral axis. For example, this is the T section, right? We will teach separately. Right? For example, I am calculating here. Okay, right. This is the area above the calculation point. Area above the calculation point. Right? Note the centroid of the selected area. Sir, this is the centroid of the selected area, sir. Right? Where is the neutral axis? Neutral axis is here. Right? So this distance is y. Distance is y. Right? Now I'm going to calculate this area above the calculation point into y. What is y? Y is a distance between centroid of the selected area and the neutral axis. Right? This ay is equal to q. That's it. So the definition for q is moment of the area above the calculation point about neutral axis. Okay. So v is shear force. Right? So don't confuse about v, q, m and all. We will teach separately in detail in the coming chapters. Right? Here I want to give you the overview. Right? We should not think stress is a single stress. There are 7 types of stresses. Right? 4 normal stresses, 3 shear stresses. All the stresses have different formulas. different formulas. Okay. If anyone is asking what is a formula for stress, you have to ask, sir, for which type of stress, sir? For bending normal stress, or transverse shear stress, or torsional shear stress, or simple tension stress, sir? Then once they say the name of the stress, then you can give the correct formula.